Welcome to Harmonics and Overtones by Justin and Alex.
A harmonic of a wave is a component frequency of the signal that is an integer multiple of the fundamental frequency. If the fundamental frequency is f, the harmonics have frequency 2f, 3f, and 4f, which means that if the frequency is 25 Hz, the harmonics are 50, 75, 100, etc.
Harmonics exist between nodes. Let's get a zoom in of the nodes. Some examples of harmonics. Alex Masset, he plays guitar. Many oscillators, including the human voice or a bowed violin string. Go.
A harmonic is when you have a note that is a higher frequency, a partial, but is also an integer multiple of that of the base frequency. So when you have a frequency of 25 Hz as your base frequency, the harmonic would be like 50 or 75. And this is represented on guitar when you hear the base frequency of a harmonic of that note would be something like this. Or here. Inharmonic. Partials whose frequencies are not integer multiples of the fundamental are referred to as inharmonic.
Inharmonic examples include instruments such as cymbals from the drum set, piano, strings plucked pizzicato create inharmonic sounds. In basic terms, inharmonic is any tone that, isn't a harmonic. So in a cymbal, for instance, there's many tones that aren't perfect intervals of the note. So you end up with a bass sound that's made up of many different flows or notes all brought together to bring one even tone. There's many notes brought into that. The cymbal is made out of a metal, so when they're pressing it down, they have separate notes in each area of the cymbal that all come together to make one sound, and that's inharmonics.
An overtone is any frequency higher than the fundamental frequency of a sound. The fundamental and the overtones together are called partials. Harmonics are partials whose frequencies are integer multiples, so harmonics are partials.
Some examples of overtones. Exception is a circular drum, whose first overtone is about 1.6 times its fundamental resonance frequency. The human vocal tract is able to produce a highly variable structure of overtones called formants, which define the different vowels. For example, plucking a guitar string, it will oscillate at several of its model frequencies at the same time. So when a note is played, this gives a sensation of hearing other frequencies, overtones, above the lowest frequency, the fundamental. In basic terms, the overtone is a note higher than the fundamental frequency. So when you hit a drum, you hear that basic low tone, but you also hear all the tones around it that are higher than the fundamental frequency. So you hear, obviously those are higher than the bass sound that it produces. You hit the drum, you hear all these overtones that are coming out of the drum. This is key in drumming because you want to get all the overtones equal, so you get a nice crisp sound that sounds around the same note. Obviously, perfect sound is pretty much impossible, but as drummers we want to get the most crisp sound out of our drums. So it sounds great.
Timbre is the quality that gives the listener the ability to distinguish between the sounds of different instruments. The timbre of an instrument is determined by which overtone it emphasizes. A carefully trained ear can hear these changes even in a single note. This is why the timbre of a note may be perceived differently when it played staccato or legato.
Some examples of timbre: piano versus guitar, vocals versus didgeridoo, bells versus harmonica, slide whistle versus recorder.
Timbre is the distinction between two different instruments, just like a piano and a guitar. So, a C on a piano sounds like this, but a C on a guitar sounds like this. And you can tell the difference when we play together, like right now.
So that's
timbre. This is an example of harmonics and overtones in practice.